Herkese merhaba. Hello everyone. I'm from Turkey. I am Murat Aydin. Today I will present to you my research, what is BIM-based automated code complete checking. You can contact me with the emails, and also you can access my ORCID page with this QR code. You can also access my Google Scholar and SearchGate web pages with this QR code. Here you can read my short biography about myself. I completed my construction science doctorate program in Istanbul Technical University by receiving the most successful doctoral thesis award of 2021. I continue my academic studies in the field of project and construction management as an academician at Ankara University. Also, I've been working in the BIM subject area for a long time. This is my Google Scholar webpage, and this is my ResearchGate webpage. You can find and read my publications on both web pages. Let's start with the presentation. BIM, or Building Information Modeling, is a simulation prototyping technology. The definition of the BIM, according to the US National BIM standard, BIM is a digital representation of the physical and functional characteristic of a building project. The concept of BIM emerged in the 1970s, is discussed by academicians in various publications. The importance of BIM technology was increased gradually since the 1990s. Various BIM software has been developed by computer-aided design application providers such as Autodesk, Graphisoft, Bentley, and etc. A high level of interoperability and cooperation is essential to enhance expertise and automation in the construction industry. The required data must be represented correctly according to the types, characteristics, and names to a building project. To build a building, and BIM model is a critical condition for executing many automated tasks such as building performance analysis and automated code complete checking. Many other building regulations checking is a traditional method, and it's a repetitive, time-consuming, and error-prone process for architects, engineers, and public authorities. That is why BIM's effective automated code complete checking is considered as a promising domain in architecture, engineering, and construction industry. Automated code complete checking, or ACCC, is an important task that must be handled carefully during the whole design process according to building regulations. It's a rule-based method that provides simultaneous control of building elements and building regulations, considering the building element size and characteristics and the associated regulations and codes. You can see here the cover image of the book, Building Information Modeling, Automated Code Checking and Complete Processes, as you can see here. If you are interested in this subject, I highly recommend these books to you. It's a really good book. This study is addressing the interaction between BIM and automated code complete checking. Articles on the subject of BIM and ACCC are analyzed in the study, which are accessible in the electronic academic databases. Meta-analysis method is preferred in the study, and tables and graphs are developed with the help of Microsoft Excel and Graph Common website. Let's start with the background of the automatic code complete checking studies. The domain of automated rules, code, and regulation complete checking has been interested in many researchers and practitioners over the years. The first completable route development study dates back to the 1960s in the architecture, engineering, and construction industry. The AISC specifications had been made using decision tables, and it has been formalized in these years. The research conducted by Famous in 1966 is shown as the first scientific study using the regulation decision tables. In his research, Famous created different decision tables with regulations, rules, and conditions. In 1973, a project was undertaken to restructure the AISC specifications. In this project, a four-layer model was presented, and this model was used as a SASE modeling methodology, standard analysis, synthesis, and expression developed by Famous and his team in 1987. Towards the end of 1980s, studies began about the development of building automated code complete checking systems. When it came to the 1990s, building models and rule checking methods have been developed. The first study on automated code complete checking has been coordinated in Singapore since 1995. The latest and current automated code complete checking systems are Coronet, Fornax, Solidly Model Checker or CMC, Jognidia Model Checker, StatPeak, Smart Code, Design Check, Lika, ACC PEP, GTT and etc. The present studies have shown the possibility of various rule generation approaches and applicability to automated code complete checking by many countries. The Republic of Korea, Norway, Portugal, the United States of America, Australia, the Republic of Singapore have given importance to BIM-based automated code complete checking studies towards increasing the quality of design. The meta-analysis is the method of combining the results of multiple studies independent of each other. It combines the results of studies done in different times, places, and centers on the same subject, and it makes a general conclusion about the related topic. The research questions of the meta-analysis methods are what is the basic info, what is the content, what are the form, input, and output, and what are the purpose and outcome. As a result of the search, as shown in figure 1, 168 articles are found, 131 are articles, and 37 are proceedings. Only articles are included in the analysis to achieve a confident academic standard. Only leading international electronic academic databases are used within the scope of the meta-analysis studies, and the research areas are limited to architecture design, automation, building codes, engineering, environmental science, construction industry, and construction building technology. The meta-analysis template consists of four main categories: data, content, form, input, output relationship, purpose, outcome relationship. It was prepared with the help of the frameworks of similar studies, and each category was subdivided into subcategories to provide detailed information. 131 articles were transformed into a comprehensive table with Microsoft Excel. Bar charts were used for the data category, and in other categories, interactive map networks graphs with the Graph Common website were used to express subcategories relationships. Graph Common is a collaborative platform for mapping, analyzing, and publishing data networks. It empowers researchers, people, and organizations to transform their data into interactive maps and untangle complex relations. Let's start with the first category, data category. Data category consists of 10 subcategories: article type, keyword, author, institution, country, source, publisher, year, database, and area subcategories. 98 articles are published directly in journals. 33 are published as selected papers at congresses. The most frequently used keywords are building information modeling, building information industry foundation classes, building information model, and building codes. Sorry, here. It is seen that the number of articles in which two authors are the highest. In general, the articles are prepared by large groups. This preparation shows the research studies should be supported by all the disciplines involved in the construction activities. Most of the articles prepared in universities. The first authors of the articles are mostly academicians. Most of the articles are prepared in the USA, China, Australia, and Germany follow the USA. Most of the articles are published in the International Journal of Information Technology in Construction, Journal of Computing in Civil Engineering, and Automation in Construction. Most of the articles are published by the American Society of Civil Engineers. The number of articles has increased steadily between 1995 and 2011. BIM and automated code copy checking have gained importance after 2011. It peaks in 2014 and 2016. Most of the articles are obtained from the engineering village, and most of the articles are performed in architecture, engineering, and construction industry, or AEC industry. The second category, content category, consists of three subcategories: subject, study level, and process. The starting point, where you can see here the red dots, shows the subject category. The H colorful arrows, as you can see here, shows the study level subcategory, and the endpoint, blue dots, shows the process subcategory. As shown in figure 5, most articles are based on automated code complete control. And most articles are discussed at the project level. And the articles are directed to the whole life cycle. The third category, form input-output relationship category, consists of three subcategories: method, data type, and contribution. Starting point shows the method subcategory. The age shows the data type category subcategory. The endpoint shows the contribution subcategory. As shown in figure 5, as shown in figure 6, the case study is the most common method used in the articles. The most of the articles based on quantitative data, and the contribution of the articles to subject area is discussed in the contribution subcategory. Model creation, here, general evaluation, system development, and statistical results are the most common contributions of the studies, respectively. Model creation is generally directed to the design of a BIM model. General evaluation is related to the automated code complete checking software applications and new trends. System development focuses on the development of a BIM-based automated code complete checking system. Statistical result is based on the statistical results of the BIM-based model and code complete checking application. The last category, proposed outcome relationship category, consists of three subcategories: problem, tool, and result subcategories. The starting point shows the problem subcategory, red dots. The age shows the tool subcategory, and the endpoint, blue dots, shows the results subcategories. The requirement is reached in most articles in the problem subcategory. When we check the article reasons, the necessity of a BIM-based automated code scope checking and the importance of interoperability with practical BIM for compatible building regulation rules is emphasized in many articles. Software usage is rich in most of the articles. National software and international software are preferred as a software usage tool in the articles. Proposal enrich in most of the articles. The results of the articles emphasize the importance of automated code complete checking, and several articles propose a new automated code complete checking system. And finally, this study carries out a literature review by analyzing the articles on automated code complete checking through BIM. This study gives the general situations, research trends, and develop or propose software features. The articles impact the interoperability between automated code complete checking and BIM application. The article emphasized the importance of automated code complete checking, and they often propose a new automated code complete checking system. The automated code complete checking system helps to standardize and automate the problems of building regulation complete checking. On the other hand, emerging BIM technology and automated code complete checking have become critical issues to evaluate building performance in design and construction. Here you can find the references that I use in my research. Thank you for listening to me. See you soon. Bye. Beni dinlediğiniz için teşekkür ederim. Görüşmek üzere. Hoşça kalın.